Hello guys, today I'm going to design a 23-story tall building. The problem statement is given by Skyfi Labs. They had given 4 different plans for the first plan story 1 to 8, the second plan is for story 9 to 14, third plan is for story 15 to 19 and fourth plan is for 20 to 23. Each story categories had different live loads 5, 4.5, 4 and 3.5 but same dead loads. And in this making we are going to use 3 different types of columns and 3 different types of beams, and we are going to use auto select option in this design. We are choosing M40 concrete and 2 different types of steel, HYSD 500 for longitudinal reinforcement and mild 250. Then for slab 150 thickness we are going to use it in M40 concrete, and for defining wind load we are going to use auto draw cladding so that wind load can be applied. Its load is given as 0.2 kN per meter, and we are going to consider the parameters in Bangalore. Now let's begin. All the parameters are already set. Let's enter into it, and 4 grid lines on X and Y direction. Okay, spacing is given as 6, so let's choose 6 meter, and the number of stories 23. It's similar height, let it be 3 meters. In this 4 different plans are used, so we are going to give 4 master stories 1 to 8 a plan, so let's choose 8 as a master story, 9 to 14, so let's make it 14 as a master story, and 15 to 19, let's make 19 as a master story, and 15 to 19 must follow the 19th story, and 8 to 14 as should follow 14th story, and remaining stories should follow story number 8. Okay, grid only option is chosen. We are going to enter into it. Now the grids are ready. Let's define materials. First we are gonna choose M40 concrete. And then steel rebars, which is mild 250 and HYSD 500. Okay, let's define frame properties. We are going to add first the concrete beams. Beam of sizes 300, 500, 350, 550 and 400, 600. Of M40 grade, depth is 500, and width is 300. For reinforcement, longitudinal bars HYSD 500 and confinement bars let it be 250. This is a beam, and of cover 25 mm. Okay, one beam is created. Let's make a copy of it. let's name it 350 cross 550. The depth is 550, the width is 350. Okay, and again make a copy of it for the third beam. Let it be 400 cross 600. The depth is 600 and the width is 400. Okay, now we have to make an auto select option. It's here. Let's name it auto beam, because we are going to use the same for the column also. These three types of beams, let's add it, and auto beam is here. Now it's time for concrete column. Now the size is 500 500, 550 550, 600 600. So let's make it 500 cross 500, 40, 500, 500. Reinforcement as HVSD 500 for longitudinal and mile 250 for confinement bars. Okay, let's make a copy of it. Now 550 cross 550, and one more for 600 cross 600 column. Okay, now again we have to make an auto select for three types of column. Let's name it auto column. It's concrete. These three columns added. Now auto beam and auto column are ready. Now let's go for slab. Slab 1 is there. Let's make changes on it. It's 150 mm and 40 concrete. Okay, now let's move to the first story. Story 1. Let's choose similar stories. Begin with concrete column. Let's choose auto column throughout the grid, and here we can notice that up to only story 8 it is drawn because of similar stories option. And for beam, choose auto beam. And for slab also, slab 150, and we made it. Now it's up to 8 story. Let's go to story number 9. For story 9, it's slightly different. Same way for beams and slabs. And it's up to story 14, so let's move on to 15. For this plan, it will be like this. Similarly for beams, beams in this way. Let's cover it with the slabs. Okay, 15 to 19 is over. Now let's move on to 20. For 20, the plan looks like this. And now the modeling part is over, the drawing part is over. Let's define loads. For loads, dead load 2 kN per meter square is uniform throughout the building. Dead load of 2 for all the floors. Let's select all the floors and apply. Now let's go for live load. Live load is different for different stories. For the top 4 stories, the live load is 3.5. And for the next category, the live load is 4. And 9 to 14, it's 4.5. And for the first 8 stories, the live load is going to be 5 kN per meter square. Okay, now the shell loads are applied. It's time for cladding load, which are applied only on the external or outer beams. Let's deselect the joints and apply a load of 0.2 uniform load. And let's move on the next plan. Let's apply 0.2 kN per meter square. And we are going to the next category. All the external beams are selected. Let's again apply the 0.2 kN per meter square. And for the top, let's make it 0.2 kN per meter square. And one more thing, for the topmost story, there are no wall claddings on the top. So for the external beams of the topmost story must have no load. Let's delete the existing loads. Okay, now the wall loads and the shell loads are applied. Now for the base story, we are going to apply restraints which is already pinned, or maybe, yeah, there are no supports. Let's fix it. Now the supports are fixed. Before that, one story option should be chosen. And it's going to be fixed. Okay. Now it's time for wall cladding. Draw. Auto cladding use flows. Okay. The wall cladding is drawn. Now it's time to load patterns. Let's define wind load. And we choose IS875. Add new load. Let's modify it. And in IS875 part 3, we are going to use this. This code here in Bangalore. So for Bangalore, let's choose 33 meter per second. And let the category be 3. And okay. And we have to apply it. Assign shell loads wind pressure coefficient. For assigning it, in this table, H by W is to be checked. Our total height of building is 69 and width is 18, so it comes in the range of 3 point something. This two categories are given. L by W, our length and width are same, so it's 1, so it comes in this category. This category, the windward side is 0.8 and minus 0.25 on the opposite side and minus 0.8 on the other sides. Let's apply this on the ETABS file. 0.8 on the windward side. For that, elevation is set to A. Let's choose all stories. All the cladding are selected and applied, and some of the missing claddings are chosen here. Apply. And now on the other side, it's given minus 0.8, minus 0.25. Also, it's on leeward side. Choose them all and apply it. Also, the missing walls are here. Let's choose them too. Now on the other two sides, it's minus 0.8 and it's leeward side. For that, let's choose one. Make sure the all stories are selected, and we are going to do it for the all the views, all the grids. and grid number 4. Apply. Now for any story, the wing loader applied here. So the loading is over. Now let's analyze the model. Analysis is complete. This is the deflected shape of the building. Let's go for design. Let's view the preference. It's already fixed as IS456, so no problem. Start design. We are given the option auto select, so it uses only the minimum size of the given beams and columns. If something fails, it shows that some members haven't passed, so it asks us to reiterate. Let's check whether every elements are passed in this or not. It shows 705 frames are to be deferred. Let's reiterate it. Analysis over. The design runs. Seven not five frames are being changed to the next best shape or next best section. There's still one frame is failing. It's asked again to reiterate. It completes the analysis, and now the design starts. Again, one more frame, the same frame. The design is complete. Let's check the design. Let's verify all members are passed. Yes, all the frame members are passed. And thus, the design of the 23-story tall building is over. You can detail it, and the reports can be found here. It's working. And it can be printed or it can be exported to Word document. The whole report is given here. So that's the end, and thank you.